Morning. It's Friday. Friday's supposed to be kind of an easy day, but I think this lesson for some of you might be a little bit more intense. Um, it's actually, I know I say this a lot, but it's actually a pretty easy assignment, but there's a lot of steps to it. There's only 3 problems today, um, but if you stick to it um, and you follow the process that I'm going to outline to you, I don't think it'd be that complicated at all. There's a little bit of arithmetic, but again, you can use your calculator. That'll save you some time today. But let's talk about surface area after the little comic strip here. Again, it's Foxtrot by Bill Ammond, and if you haven't ever seen any of these, you're missing out. This uh, little kid, I think his name's Jason, and he has a tremendous brain for mathematics and science, and so it's kind of fun to read the comics if you're a math teacher. Here he's at a counter, and he's saying cylinders, nope. Pyramids, nope. Spheres, hemispheres, nope, nope. Hexagonal prisms, nope. Planes, nope. Dodecagons or dodecahedrons, nope. Ring tori, nope. You're telling me all you have are cones? Yep. And so now we're figuring out it's an ice cream shop, and the next picture over here is Jason and his brother, and it says, the ice cream industry needs to hire some geometry nerds. And the brother, who is in the comic strip, is not supposed to be near as bright. He says, would a waffle plane be infinite? I'd totally get one of those. We talked about planes yesterday, and that would mean infinite ice cream, which would be great for the first couple weeks, don't you think? Okay. Everyone knows a little bit about surface area, but hasn't really talked about it too much. This is just a regular box. This is one of the boxes you get in the mail. And every one of you, I'm sure, has taken a box apart. This is a pretty good sized box. I've got another uh, three-dimensional cube here. We'll talk about that in a minute. But if I take the box apart, all boxes are made out of cardboard, and most boxes are made out of one sheet of cardboard. So I know you can't see this whole thing, but every part of this cardboard box is attached. So when I lay it flat, every part then stays attached. There's no pieces that fall off. This is what's called a net. A net is when you put a two-dimensional object is the net, and then the box, or in this case, it's a rectangular rectangle rectangular prism, not a cylinder, and so it's set up like a three-dimensional box or square rectangle. So there's the rectangle here on the surface, but it goes all the way down to here. So that's how we figure volume, is we figure length, width, and then height of the box. So we multiply those three together. Basically what you're doing is you're finding this surface, length times width, and then you're multiplying it by how many of those there would be. That's your height. Okay, so that's what volume is. But for surface area, you're figuring out what that net is, how much space it would take up. Okay, let's look at that on a little smaller thing. So I used a regular piece of graph paper here, and I cut out a cube, and I made my cube like this one with 6 sides. Right, this is a pretty cool little dice. It's an electronic dice. If you haven't ever seen that, awful bright in the video there. I just rolled a 6, so that's pretty neat. It works off of a little bit of motion. If the batteries are good, it's real sensitive. And when I slam the desk drawer shut, 3. When I slam my desk door shut, it goes off automatically, and so it's kind of a weird deal. But anyway, I cut out a box, and you've seen this before. Now, this doesn't have any extra tabs where I would tape it together. I've cut all these pieces off, and I made it so that each square is equal to the same as each one. So I basically have squares, and when I lay them flat, that's what I cut out of the paper. So there's 1, 2, 3, 4, 5, 6. Just like the dice, you'd have a front and a back. You have 4 sides around there. Okay, so if I wanted to call this the front and this the back, we'll go ahead and label those. This is front, this is back. Then I could fold it up and identify the other pieces too. So if here's my front, then the opposite one is the back. Okay, and then I could do that with, like, okay, here's the top and here's the bottom, like that. Front, top, bottom. And if I move my front towards the bottom of the screen, then I could have a right and a left. So all these pieces two-dimensionally will then match up with its side three-dimensionally. Okay, so basically, you've taken a three-dimensional object, you've done the opposite of the box. You've taken a three-dimensional object and turned it into a two-dimensional, or you take a two-dimensional object and cut out another one, and you fold it up into the box. All right. Why that's important in surface area is that if you were to paint this box, or if you were to get some wrapping paper, or we used to use a lot of contact paper or wallpaper, and you paste that or glue it on, or just if it had adhesive, you stick it on there to the box, and all you had to cover was the outside of the box, right? In this case, when we take this box apart, it's got extra pieces right here, but that's to make it foldable, right? So that's part of the net, but we're not going to really think about that. We're going to think about, what if I was to paint this box? Then what would I need? Or what if I was to put paper over it? What would I need to cover it? Okay, that's what surface area is. We've talked about area. If you find, if your teacher asks you to find the area of this, then you would probably count the little boxes. Let's see, there's 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 by 8. So just that one is 64, right? Well, what's the whole thing going to be? This is 64, and I believe these are, we can measure with our ruler here. They're not centimeters, because centimeters are long like that. So they're a third of a centimeter. You can't see that very well, I noticed on there, but so we would just have to call this units probably. Okay. So that's 64, this is 64, this is 64, this is 64, this is 64, and this is 64. So if I asked you, what's the surface area of this cube, then what you would do is you'd find 1, which we did is 64, and you'd multiply it by how many there are. Well, on every cube and on every rectangular prism, there's an equal number of sides. There's 6, right? There's always 6. Now, not all sides are equal. They are on a cube. But on a rectangular prism, such as that box, they weren't all equal. Anyway, if I asked you to find the total surface area, you would just add all these up. 1, 2, 3, 4, 5, 6. Or you'd go into your calculator and you do 64 times 6 and give me the total. Okay, that would be your area. How many little boxes are in this? Well, that's 64 times 6. Now, if you wanted to treat these like inches, I don't think they are. Yeah, they are. These are inch squares. So that's why they're in eighths, because they're each an eighth of an inch. If you put that up there, here's our 1 and our 2. You're not seeing that very well until I zoom in, but each of these boxes measure an eighth of an inch. So this is good graph paper for American construction, because it's all based off of the 1 inch. So inch by inch, these are 1 inch squares. That's easy, because then there's 1, 2, 3, 4, 5, 6, 6 inches squared right there would be our surface area. Okay, so summarize all that talking and mess up. If you're trying to find the surface area of a box, cube, anything that is based off of rectangles or squares, which squares are rectangles, then you're going to have 6 sides to deal with. So that brings us to today's work. On today's assignment, you're looking at this volume and surface area, you're looking at this side. Now, I have had people in the past that said, but that's the same assignment as yesterday, Mr. Nelson. Well, if you look close enough, it's the exact same pictures from yesterday, but it's not the same instructions. This one's find the surface area. Yesterday's was find the volume. And there's only 3 of these. I didn't put the one with the fractions on it because that would take a lot more time. And if you get it with these first 2, then you're going to know the answer on the other one. I was working on this yesterday and I made a little error line. Just ignore that. It shouldn't be on your paper anyway. So find the surface area of each of the boxes. One of the best things you can do is to organize your work here. And you can do something like label the sides if you want. I would call this one here the front, okay? So this right here, if I shaded just the end piece, I would call that the front. Okay, I'm going to go ahead and write that out. That's the front. And then that means this one back here is going to be the back. Okay? And then I'm going to have a top piece. See that big panel that would fit there on the top? This looks like a glass prism. And so I would call that the top. And of course, if you're going to have a top, then you end up having a bottom as well. So we've got 4 sides. Now remember, it's always 6-sided figures when you're talking about rectangles and squares, because you need 6 sides to attach them. Now, if for some reason someone gave you a problem where it was an open box, or what they call sleeve, then you wouldn't include the front and the back, and you'd find just the sides. That'd be nice and easier, because you'd have 2 less problems to do. But so you have to rationalize. You have to think about your situation, and we'll talk about that when we get down to the truck problem below. Anyway, we've got front, back, top, bottom. I like to use left and right. This is our left side. This is our right side. Sometimes people put side 1 and side 2. For me, it's just, if you're calling everything a different word, then that kind of tends to line it up better. Okay. And then I don't want to do your whole work for you, so I'm just going to do maybe 1 or 2 of these. But remember that these numbers apply to other lines as well. So this is 6, right? From here to here is 6. But that means, because these are perpendicular lines, that means that this one is exactly the same length. And if you get when you get into high school geometry, there's actually proofs you can do to prove that those are the same lengths. Even though everyone knows it, you can mathematically prove that they're the same length. So this is 6, this is 6, this is 6, and this is 6. There's 4 line segments here that are 6. So the question could be asked, why don't they label everyone? Well, can you imagine how many numbers are going to get on there and how confusing that is? So if we assume that people can see the basic size similarities, 6 and 6, then we only have to number that once. It makes life a lot easier, a lot less confusing. So on our front, we have a length of 6, or we could call that a base. Remember, our area formula is base times height or length times width, right? We could call it either one. In this case, base times height would make it a lot easier to work with, maybe, because this is a base and this is a height. But again, it doesn't matter. You've got 2 numbers and you're multiplying them together. So for the front, I'm going to take 6 times 5. So I would write 6 times 5, and most of you are going to go ahead and solve that. Most of you already have. So that's 30. Now you might notice that because we chose to pair these off as front and back, that is exactly the same value, 30, and then this is also 30. So you don't have to show your work there because you've already done that, all right? The top has the different measurements. This is 6, but this is how much? Well, down here was 12. That means all of these lines that are parallel are also going to be 12, okay? So to do the top, I'm going 6 across and 12 back. My base is 12, my height is 6, or length and width, however you want to look at that. So I'm going to put 6 times 12. Order really doesn't matter in that case. So whatever you want to do, and that's going to be 72. Top 72, so is the bottom. So here's a question for you. Is the left and the right also 72? Hopefully you said no, because if you're looking at this, you see that the height of the sides is 5. Up here it was 6 on the top and the bottom. But this time we're going to go with 5. So we're doing 5 times 12. 5 times 12. Okay. One nice thing, if I would have lined that up better, then you would have seen that we have two 30s and two 72s and two 60s, but I guess you can see that anyway. And then so you want the total surface area, and all you have to do that is add up all the sides. Well, we figured them out. 30 and 30 is 60. Here's two 60s, that makes 120. Add that 60 to it, it's 180. And then we can add the 72 and the 72. I'm not going to do that for you because I'm pretty sure that I've done almost every step of that problem for you, and I want you to be able to do it. Now this one, you're going to have decimals, so remember to make sure you put that decimal place in the right spot. Rounding is probably not a good idea on this one. Use your calculator if you want. That's a good idea. Okay, let's move down to the bottom of this one. Got to readjust my camera just a little bit, and maybe bring it in a little closer. Okay, if you want to paint the truck, how many square feet will you need to cover? Well, in class we'll have, if we can this out, I would have a little discussion with you about what part of the truck would we actually paint. Would we include, some kids ask about the inside. Well, we're not going to worry about the inside. We're going to paint the outside surface area. But would you include the bottom? Yeah, you probably would. You wouldn't leave that rust colored. You wouldn't leave it just original, because it would rust. In fact, it's probably more important that the paint on the bottom is there to protect from the road residue, the salt, and the other things that would erode and rust up that bottom. So you would definitely paint that. Same with the front. Even though it's behind the truck, you would still want to cover that with paint. So we're going to assume that you're going to paint all 6 sides on this one. If someone's already done this paper and they didn't include that 6th side, if you've still got it in your possession, it's easy to fix. But if not, I'll give you credit for still doing the 5 sides, but it needs to make sense. You need to have thought through the problem to make sure that you knew which 6 sides are being painted and have a little bit of rationale or justification for your answer. All right, anyway, let's double check. Make sure you can read this. I know you can't from my screen very well, but on your paper, make sure that you know that that's 7.50 feet, right? I'm just going to put 7.5 feet because an extra decimal place with a 0 doesn't really matter. In fact, it can get in our way. That's the width, but also the height is 7.5 feet. But the length of the truck. So the back is a square, 7.5 times 7.5. This part right here, 7.5 times 7.5. But the length of the truck is 15. Okay, so that's going to be 15. Hopefully you can see that. If not, now you don't have an excuse because I wrote that down. And then you've got to find your different sides. So you've got a front of the truck that's up there by the bed. You've got a back. You've got a top. And you've got a bottom. And then you've got the sides. So this could be driver's side. I notice we've got 2 B's, but if you keep them organized like this, that won't be a problem. If you put a little A for back and a little O for bottom, that would be good there. So we've got the driver's side, and then we've got passenger side, or left and right works great for this one too. So to finish that problem out, all you have to do is 6 little problems on the measurements for those. And actually, you'll find on this one that it's a little easier because some of these match up. If you notice, you've got the top, 7.5 times 15, is also the same as the sides as well, 7.5 times 15. So 4 of these numbers are going to be the exact same thing. And then you can go 4 times something on your calculator and then add in your I guess they're on the bottom ones here. And then you'd add in your top, your front, and your back, because they're the different measures. Top, bottom, driver's side, passenger side are all the same, but your front and the back will be different. Okay, that's it for today. You have 3 problems, and then get ready for no math next week. We're going to do, well, you should still do some freckle, but we're going to do a science project um, that uses a little research to report on some information. All right. We will talk to you through email or Zoom. Hopefully, you can log on and see me sometime next week. And then watch your email, because there's kind of a cool surprise that we get to do at school. So watch your email. Email me if you have any questions. Talk to you later.